Okay. Good morning, everyone. We are Atom Smashers. We offer tutorials for first years and School of Mathematics and Natural Sciences, or unquote. All right. So today I've prepared an interesting topic for you guys, and quadratics. Under quadratics, yeah, that's discriminant. Yeah, then under discriminant, that's where you can find the roots of alpha and beta. Yeah, so under that, the only important thing you have to know, you guys, is that first you have to know how to derive the formulas. Once you know how to derive the formulas, then you know the identities. Once you know the identities, now you can know the general formula if you want to find the equations of the alpha and the beta root. All right. Okay. So yeah. So the alpha and the beta. Yeah. So I think for you guys who are trying to more like practicing on what you're studying, you might come across such kind of questions in the past papers where you see the alpha and the beta root. Okay, so these are coming from what's the quadratic. So they're coming from quadratic. So this is the general quadratic. Okay, so now we can derive the formula. Say the formula. Okay, so say is ax squared plus bx plus c is equal to 0. Then we can get rid of the coefficient of x by multiplying the entire of the equation by 1 over a. Then this a, we'll eliminate that a, then here to leave us with the denominator of a, even there a. All right, then this will be x squared plus bx over a plus c over a, then it's equal to a into 0 is 0. Yeah, so we can keep this. Okay, then we can say that let alpha and beta roots be, let alpha and beta roots be x minus alpha, then x minus beta, which is equal to 0. Then from here we can do more like we can expand. So x will multiply with x minus beta, then negative alpha will multiplied by x minus beta, which is equal to 0. Then x multiplied by x, you have x squared, then x there, you have minus beta x, then there minus alpha x, then there times that got positive alpha beta, which is 0. Okay, then here 2, then negative is common, say minus, even x is common, so if we factor out a positive from here, we remain with b, then there are plus alpha, then x there, then plus alpha beta, which is equal to 0, like that. Okay, Then from there I can say x squared minus. So we know that addition is what is commutative, right? So if I write as alpha plus beta x plus alpha beta, which is equal to 0, right? Okay. Then from here we can now equate this the sum of these roots to our general quadratic, then the product with this from the general quadratic. Okay, so we can say negative alpha plus beta x, so it will be equated to bx over a. Okay, so we can divide throughout by negative x, then divide by negative x. So this and that to go, then this and that to go. So we remain with alpha plus beta, which is equal to bx over a, should be divided by negative x. Then alpha plus beta should be equal to bx over a multiplied by 1. So this is over 1, right? Then if we change the sign there, we put a multiplication, the denominator becomes the numerator, then the numerator becomes what? The denominator. Right, then we have 1 over negative x. Then this x can cancel with that x. Then we have alpha plus beta, which will be equal to negative b over a, like that. So this is an important. So where you see alpha plus beta, which means it's negative b over what? Negative b over a. All right, then I said the sum of the roots will be equated to the sum from the general quadratic. Then the product will be equated to the product from the general equation. So we say alpha beta, which is equal to what? C over a, like that. This one, there's nothing like solving or coming up with this is direct. Okay, so the formulas which you have driven are alpha plus beta, which is equal to negative b over a, and alpha beta, which is equal to c over a. Okay, please know this, right? Tristy, know these. They are very, very important. Know these. If you know this, then the next is the identities. The identities. The identities.